Hey, welcome back. We're going to start on the first of four exercises following the reading that we started in section 3 of part 2. The first exercise is called Age Check. We're instructed to please write a program which asks for the user's age. If the age is not plausible, that is, it is under 5 or something that can be an actual human age, the program should print out a comment. Have a look at the examples of expected behavior below to figure out which comment is applicable in each case. So we prompt the user, what is your age? The input 13 says, okay, you're 13 years old. What is your age? 2, I suspect you can't quite write yet. And then what is your age? -4 says that must be a mistake. All right, so we're gonna need a variable called age, which stores an integer from what the user inputs. So it says, what is your age? Question mark. And then we want to check if age is less than 0, or should say less than 1, then we want to print that must be a mistake. So let's run this first, and let's give it, -4. It says that must be a mistake. Let's run 0. That must it can't be 0 years. Let's see this way. I think you might need to put it less than 0, but I think less than 1 is logically what makes sense, right? Because if you're less than a year old, then it's right. Let's just do 0. Let's just be safe and do 0. Because you can't be negative years old, right? Okay. Then it asks us, so I think this might be the second condition we want to evaluate. So it says if age is greater than or equal to 1 and age is, let's say, less than or equal to 3, right? Because at what age do kids learn to write? I think between what, the age of 3 and 7? So let's just print, I suspect you can't quite write yet. I'm sorry, you can't write quite yet. Pardon me. So this needs to be an else if. Then here we're going to say, actually, anything be above that, we should just be able to print, okay, let's do an F string. Okay, your age years old. So let's see if this works. So if we plug in -4, again, we know that it says that must be a mistake. If we plug in 2, it says I suspect you can't quite write yet. And if we plug in 13, it says, okay, you're 13 years old. So anything above 3 years old, 3 and above, it should write the same thing. So let's test this and see if we pass. Okay, we failed the condition. From output, okay, your string, I suspect you can't write quite yet, is not found when input is 0. So we must be inclusive to 0. So let's run it and test. Say, okay, you're 4 years old. String, I suspect you can write it, is not found. Okay, so I guess it wants us just to go all the way up to 13 years old, maybe 12. Okay, it wants us to go to 4. All right, so let's test this now. It should work. And there we go. So again, don't ever be afraid to, just keep running the tests. So they didn't do it with the AND statement. They just did it. If age is less than 0, then that must be a mistake. And then if age is less than 5, I suspect you can't quite write yet. And then else they printed this out. So pretty similar, but we just did the AND operator. But yeah, this also works. So you can use my solution, which again will be in the description in the GitHub repository, or you could use this. And if you create an account on the programming course and also go to this link, tmc.mooc.fi, and create an account, it will let you check what solutions are the course instructors submitted, and compare them against yours. But you can only see these solutions once you submit yours and it's approved, right? Once you input here and the IDE accepted because your code passed all the tests, then you can be able to go see the model solution. But this is what we did. And I think one of those things that I have sort of a problem with the course is that sometimes they don't tell you if you should be using logical operators or not. My assumption is that, especially when I do these solutions, I try to use what the latest material we learned is in my solutions, because I want you guys to be able to see these solutions. I mean, the course material in action. So I would have liked if they sometimes also told you, hey, make sure you use and or blah 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 blah. But you don't have to. If you can make your code work without it, the IDE will pass you as long as your code passes the test. They don't check specifically whether or not specific conditions are being applied. I mean, if specific operators are being used. As long as your code works, I think the IDE will pass you. So this is our solution. Again, it will be in the GitHub repository, so make sure you check it out if you want to compare to what you came up with. And this is the model solution. Again, you can pause the video here, take a look at it, digest it, and see how it compares to yours. I will also always recommend that you try the exercises on your own first, see if you can pass them on your own, but you're more than welcome to follow along with me as I take on these exercises during the videos. Okay, let's continue. Here we have another exercise called nephews. It says, please write a program which asks for the user's name. If the name is Huey, Dewey, or Louie, the program should recognize the user as one of Donald Duck's nephews. In a similar fashion, if the name is Morty or Ferdy, the program should recognize the user as one of Mickey Mouse's nephews. So here's some examples. Please type in your name, Morty. I think you might be one of Mickey Mouse's nephews. Please type in your name, Huey. I think you might be one of Donald Duck's nephews. Please type in your name, Ken. You're not a nephew of any character I know of. So this is awesome. This should be pretty easy. I'm just going to copy this whole thing here. I'm going to paste them here. I'm going to say first, name is equal to input. Please, we don't need to do any typecasting because we're going to be evaluating strings. So please type in your name. Then we're going to say if name equal to any one of these. So it could be Huey, or, in fact, this is what I copied this for. Or name equals, actually, yeah, in Python it's double equals, not triple equals for evaluations. Dewey, I need to put this in strings, or name is double equals to Louis. Then we want to print and I'll just clear this line. I think you might be one of Donald Duck's, wow, Donald Duck's nephews. Then we're going to say elif name is equal to Morty, or name is equal to Ferdy. Then we're going to print I think you might be one of Mickey's nephews, Mickey Mouse's nephews. Then at the end here, we're just going to do else, print, you're not a nephew of, wow, any character I know of. Okay, so let's try this and see if it works. Invalid syntax on line 3. What am I writing? Am I writing this incorrectly? Let's go up here and check the notes. How are they structured? The or. I just realized they never gave us an example of the or at work. Anyways, I think we do this. Okay, so I think it might be then. I'm so sorry. I'm using the pipe symbols here. I'm so used to other programming languages. This needs to be or, like that. Pardon me. Right, in other programming languages, we use the double pipes for the or symbol, not here in Python. That's my apologies. I am so sorry. Let's run this. Line 5, we have a issue. If name equal Morty, or name equal, yeah, this right here, Ferdy. Let's run it one more time. Okay, so here if we plug in Huey, it says I think you want to be one of Donald Duck's nephews. And then if we write in Morty, you might be one of Mickey Mouse's nephews. And if we type in Ken, it says you are not a nephew of any character I know of. So let's run this through our tests. And there we go. We can take a look at the model solution. And they did the same thing. Check for Huey, Dewey, and Louie. And then check for Morty or Ferdy. And then otherwise just print it out the last statement. So this is exactly what we just did. So you can take a look at my solution here. Again, solutions will be up on the GitHub repository. You can find solutions. They'll be uploaded before you can even get a chance to look at this video. So you can click on the link below to go take a look at them and compare notes. But yeah. Okay, we have another exercise here called grades and points. The table below outlines the grade boundaries on a certain university course. Please write a program which asks for the amount of points received and then prints out the grade attained according to the table. So if you get less than 0, the grade is impossible. If you get between 0 and 49, you fail. 50 and 59, you get a grade of 1, 2, 3, 4, and 5. Otherwise, impossible. So with square brackets, I'm assuming this is inclusive. So it includes 0 up to 100. Grade is failed. I'm sorry. That's not what this means. I'm getting ahead of myself here. How many points? So this is the code, how the code should be evaluating. We get prompted how many points between 0 and 100. We're typing 37, says fail. How many points between 0 and 100? 76, grade of 3, and a grade of -3. So we're going to have a variable called points, which is going to store an integer. And we ask how many points, 0 to 100. And then here we're going to say if points is less than 0, then we want to immediately just print impossible. Or, again, I'm doing the same mistake, or points is greater than 100, right? Because we know our limit, anything above 100 is impossible. So these two will return the same exact response. And it's impossible like that. Oh. Okay. Then we see if grade is between 0 and 49. I'm assuming this is going to be inclusive. So elif points is greater than or equal to 0 and points is less than or equal to 49, then we want to print fail. Fail. Like that. Then between 50 and 59, then 60 and 69. Then we're going to say elif points is greater than or equal to 50 and points is less than or equal to 59. Then that's 1 all the way up to 5. Let me print 1. elif points is greater than or equal to 60 and points is less than or equal to 69. We print 2. In fact, what we could do here is just copy that, highlight that, press Shift, Alt, and the down key, and it's just going to duplicate that line for us. And we can just go ahead and change this between 70 and 79. Grade of 2. Do this 2 more times for 80 and 90. So this is going to be 80 to 89. Grade of 4. And then 90 to 100. And it's going to be a grade of 5. And then, all right, so that's it. So let's run this and see if we plug in -4. Oh, pardon me. -4, then it says impossible. If we plug in 101, it also says impossible, right? Because you can't get a grade higher than 1. But otherwise, if I plug in, let's say 39, we fail. That's what we were expecting. 37 give us a fail. If we plug in 76, we should return grade of 3. Pardon me, 76. Yep, grade of 3. And then if we plug in, let's say like 92, we get a 5. So let's test this. Okay, so we failed one of the tests. So, okay, so it wants us to track the grade. So we can do here, So what we could do here is grade. So actually, it was only worried about the value, the integer value. So instead of just printing 1, we could just say grade is equal to 1, and then we could just uh, print the grade. So let's test this again, see what it does. When input is 50, no, that works. Oh, I apologize. The formatting is wrong. So I need to put grade like that. So it's just going to make this like that. So we'll do that. Say grade to 2, grade to 3, grade to 4, and grade to 5. I think that's might be the problem here. So let's test this again. Yeah, that was the issue. So that's my bad. Just didn't read the expected output clear enough. But I think that should have been the solution, unless I'm having some network issues. Give me 1 sec. Okay, so I was having a network issue. As you can see, solution didn't change at all. The only problem that we're having is that they wanted us to print out the grade like this. Originally, I just had printed out the value of 1 because I was reading this kind of too closely. But the expected output was like this grade, and then it prints out a number. And then otherwise, the grade is impossible. So, in fact, here I should have said for these two, grade is equal to string impossible. And then like that. Put a comma here, go to the end of the line, get rid of this. And just pass the grade here, like that. Again, if we test this, oh, no, we got a problem. Oh, it's supposed to be, I'm sorry, it's supposed to say fail here. Right, there we go. So we can view the model solution. And again, they did the same thing. Grade is equal to impossible, and at the end they printed grade. This is one thing I still haven't gotten used to. I know that how scope and hoisting works in Python. I feel like that should be one of those things that they covered pretty early on. But hoisting is still kind of an advanced topic. If you've done JavaScript, you've probably come across hoisting, and especially regarding code written in blocks. But in Python, you can declare variables inside conditionals and still use them outside of conditionals. So here, they have a print statement all the way at the bottom. This is a cleaner approach than what we did, but they have the final f-string print statement at the bottom, and then they just set grade. So if it's between 0, and if it's less than 0 or greater than 100, then grade is impossible. Then it go fail, 1, 2, 3, 4. And they did it this way, right? They didn't check. They didn't do it like how we did, where we check if the number falls between two numbers inclusively. They decided to just check if a number is less than an upper limit. So if points is less than 50, then they fail. If points is less than 60, then they go to 1. But we know it's above 50. So this is going to basically, it's saying, hey, we know that points now is above 50, but it's less than 60. So they put 1. It's less than 70. So it's 2. So they did it this way. But I like this way, again, because we get to use these logical operators that we just learned, like and or. So they tend to not use them in their solutions when they're teaching the material, which I don't know. I don't think that's kind of helps students ingest the material that well when they're learning new techniques. So I just decided to use them in my solution, but this is the model solution that they applied. Like I mentioned earlier, the system will pass you as long as your code passes all the tests. At least that's what I've been able to deduce so far. Maybe in the later exercises, they might add some more expansive test cases, but so far we haven't run into that. that's my solution. This is the model solution. Both work. But yeah, this is again what I was talking about when it comes to scope and hoisting. In Python, you can declare variables inside conditionals and inside code blocks. I think with the exception of functions, but I'm not sure. I'll go test that off screen and get back to you guys in the next video because I'm not sure about that. But you can declare variables inside if statements and you can have access to them outside of them. Because normally what we'll do is we'll either initialize or declare our variables at the top of our code block of our solutions, and then we'll update them as they go and then print them out at the bottom. But in this instance, but Python will let you declare and initialize variables or assign values to variables that are declared inside of conditional statements and still have access to them outside of conditional statements. So if you want to write something a little bit cleaner, for example, if you still want to go with my solutions because we're using the logical operators, what you can do is just have this grade be assigned to either fail and all the other values, and then at the very bottom here, just have a final print statement that says grade and then print out the grade, like almost like how they did. But that's the solution for that exercise. Okay, next exercise is called FizzBuzz. It says, please write a program which asks the user for an integer number. If the number is divisible by 3, the program should print out fizz. If the number is divisible by 5, the program should print out buzz. If the number is divisible by both 3 and 5, the program should print out fizzbuzz. Some examples of expected behavior. Number 9 is divisible by 3, so we respond fizz. Number 7 doesn't print out anything. Number 20 is divisible by 5, so we run out buzz. And then number 45 is divisible by both 3 and 5, right? 3 divided by 45 is 15, and 45 divided by 5 is 9. So here we have a variable called number, which stores an integer. Input number. Then we check if number. So how do we know if a number is divisible by 9 or 5? Well, we are going to use the modulo symbol. Remember, the modulo symbol is doing division by evaluating the remainder. So if we divide a number by 3 and the remainder is 0, then we know that the number is divisible by 3. So if we say if number percent 3 equals 0, right, it says if the number is divisible by 3, the program should be on front. So we want to print fizz. Then we're going to say elif number percent modulo 5 equals 0. Then print buzz. Now we could do, actually no, we should just do elif number percent 3 and number, equals 0 and number modulo 5 equals 0. Then we can print out fizzbuzz. But what I'm thinking is an else statement here would have worked, but no, actually that's not true. Because if number was actually, let's just run this first. I'm getting ahead of my train of thought here. So our test cases are 9, 7, 20, and 45. So if we plug in 9, fizz. If we plug in 7, we don't get anything. If we plug in 20, we get buzz. And if we plug in 45, we get fizz. Okay. Okay. Sorry, I'm dropping frames. So when we put in 45, we got fizz because yes, 3 is divisible. 45 is divisible by 3. But I think the problem here might be the order of how we're doing this. I think we should first do. I think we should both first do this. And then at the bottom here, do if it's divisible by 3. So this should print out FizzBuzz. This should print out Fizz. So if we, what are the test cases? 9, 7, 20, and 45. So 9 returns Fizz. 7 should return anything. 20 should return Buzz. And 45 should return FizzBuzz. Okay, so let's run this through our test and see what we do. And we passed. So, like I mentioned, don't be nervous to run your code and input the test case that they give you and see what the code does, and then just move some stuff around. So if we check out the model solution for this exercise, same thing that they did. So this condition comes first, because if this is true, also both of the following conditions are true. So if this is true, then this is true, and then they did the 3 before the 5 instead of the other way around, like how I did. But this is the solution that I did. This is the solution that they did. Same thing works. Again, as I figured out, it was just the order of what we were doing. We want to do this first because, as you saw, when we put this last, then if we plug in a number that's still divisible by 3 or it's still divisible by 5, then these will always be true, so we'll never get to this, where we have to check both if they're true. So we have to check first if they're both true with the AND operator, and then we can do them individually. So that's the solution to that. So that's where I'm going to leave this video. 26 minutes, I think, is a very good place to stop. As I mentioned in the previous videos, I try to keep these videos pretty short and digestible, so you can come in and just follow along, spend 20, 30 minutes doing the exercises, reading the material along with me, and then go on about your day. And then you can come back in another video, another 20, 30 minutes, so you don't have to spend all day, slapping away at your keyboard. Gives you a little bit of time to go ahead and think about the topics that we just learned. This is, again, another good resource if you want to use an online Python IDE that you don't want to manually start setting up Python on your computer. This is a great tool to use. onlineide.pro/playground/Python. Just go here and you can input your programs in here and evaluate them and see if they work. You can, if you're reading the material here and you see that they don't show you like how, like over here, for example, they don't show you what would happen if we plug in certain values in this code block, or they don't specifically show you how the the program will execute, then you can put that in the online IDE and then you'll be able to evaluate it. All right, so in the next video, we'll continue with the reading in part 2, and then, in this section, and then do the exercise as well, because the reading is pretty short. We'll do the remaining 3 exercises, and then that'll be the end of this section. So thank you for tuning in. Again, solutions will be up on GitHub. So link will be in the description. Make sure you go check it out. Thank you for watching.